Hello and welcome back to the virtual observatory of gaia-clim. In this video tutorial I will show some examples of aerosol data. So we go back to our main data selection page, and as the central climate variable we're now going to select aerosol optical depth at 550 nanometers. The reference is not strictly speaking a reference because the aero budget is not fully known, but it is the predominantly network available for aerosols. It's the AERONET sun-photometer network, and as a satellite we've picked the ATSR instrument from ENVISAT, and there's only one, so whether you pick all satellites or just ENVISAT, pretty much is the same. At this moment it only lists the 25 sites that have the highest number of observations in this period, and there's over 500 AERONET sites, so it gets pretty cluttered. I will just choose maybe Toulon down here, which is 250 observations during that time, which is in southern France, and we could just go and send the data request. Then we would have all the collocations within 500 kilometers and 6 hours, though usually it's a lot closer in time and also in space. We'll just fold this one in again. As you can see here, often the distances are very small, so when they measure quite often with the sun photometers, so it doesn't take a long time to record an observation. So the matches are usually or average much better than with an FTIR or a DOAS instrument, which we had with the ozone. And here we can see that the AOD values are fairly small in southern France overall, between typically around 0.1, 0.2. Also we can see the bias between the two instrument types is rather small, 0.112 compared to 0.124, that's on the order of 1%. And if we look at the difference plot and the uncertainties, then we can see that almost everything is nicely clustered, and there's no strong bias for any particular instrument here. It looks we have one outlier here, so something must have gone wrong there. So that also you can pick up with these things, and the GUI is just not smart enough at this stage to allow you to scale this independently. Though you could just with the mouse just draw a rectangle if you just wanted to zoom in and look at this with a bit more detail. You can also see from this envelope that the sampling mismatch error is one of the predominant ones amongst the errors that are known. Problem here is that we have very little error information at all on either measurement, so it's basically just the collocation mismatch error that we could estimate reasonably. We could just go back briefly and sorry, I just need to unfold this here again, go back, and this time maybe pick one of the other sides, because here's a little tick box, show all sides, so not just the top 25 but all of them, and maybe we pick a side somewhere in a desert where we know we have maybe sometimes some sandstorms and things. So I'll pick here the Hatna, which is in Arabia, on the Arabian Peninsula, and maybe just let this one go and see how that stacks up compared to Toulouse. And here you can see we do have events with much higher aerosol optical depth, and so this is then interesting events to look at. So actually you have AODs larger than one, and the nice thing is if one instrument goes up, so does the other, so that's what you would expect. And that pretty much was all I wanted to say about the aerosols at this stage, so go and explore them yourself. Have fun.